technology, there are the ever-ready tools of vector mathematics.
A quantity that has both magnitude and direction is a vector represented by an arrow. The arrow's direction is the direction of the quantity, and the length of the arrow indicates its magnitude. Displacement, velocity, and acceleration are all vectors. In equations, vectors are written in boldface. Ordinary quantities such as time and mass are scalars. In equations, scalars are written in italics. The magnitude of a vector is also a scalar, the same letter, but in italics. With vectors, even the most familiar mathematical operations acquire an entirely new meaning. For example, when two vectors are added together, the sum isn't merely a number, it's a new vector. Also, vectors can be subtracted from each other, and the result is another new vector.
These lines form a rectangular grid, at least to the extent that the spherical surface of the Earth permits. Any point on this map can be located by determining its horizontal and vertical positions. For example, picture some point on the map marked with a red dot. Suppose the red dot has the horizontal coordinate, x, of minus 150 kilometers. And suppose it has a vertical coordinate, y, of minus 124 kilometers. Whatever the distances, whether on land or sea, look like this.
Both positions are joined by an arrow from position 1 to position 2. The arrow's direction shows which way the vessel has drifted. Its length shows how far. This arrow is called a displacement vector.
With more information, the Coast Guard can estimate the path of the drifting vessel by joining the displacement vectors tail to head, which is just vector addition. They can also estimate the drift velocity by dividing the vectors by the time between signals.
A vector can be multiplied by a scalar. This new vector has the same direction if the scalar is positive, but its magnitude can be different. Multiplying a vector by a negative scalar reverses its direction.
Of course, the vectors, unlike the lyrics of certain songs, are quite versatile.
A vector can be multiplied by another vector. The dot product of A and B is a scalar that measures the tendency of the two vectors to point in the same direction. A dot B is equal to the length of A times the length of B times the cosine of the angle between them. If A and B are perpendicular, their dot product is 0. And the dot product of a vector with itself is just the square of its length.
38 bottles of beer on the wall, 38 bottles of beer. If
Moving right along,
should happen to fall.
The cross product of two vectors is a new vector, perpendicular to the plane of the two original vectors. Its length is the area of the parallelogram formed by the original vectors. Its direction is determined by the right-hand rule. The cross product measures the tendency of two vectors to be perpendicular, and it's one of the more effective tools for describing, spinning, or rotating objects.
35 bottles of beer, 35 bottles to the wall, 35 bottles of beer on the wall. If one of those bottles should happen to fall, 34 bottles of beer on the wall.
Vector algebra makes use of two perpendicular unit vectors, I and j. The little hat over the vector means that it has length 1. The vector from the origin to the point with coordinates xy is the sum of two perpendicular vectors, a horizontal vector xi and a vertical vector yj. With the help of I and j, adding and multiplying vectors can be accomplished by ordinary algebra. In three-dimensional space, a third unit vector k is used. K is perpendicular to the plane of I and j. A three-dimensional vector is written xi plus yj plus zk.
That's roughly 2 hours out, 2 hours back, and 250 kilometers each way, no more. Can the helicopter reach the Irish Coffee? And surely as important, can the pilot make it back? Wind carries the copter due north at 40 kilometers per hour, 80 kilometers due north in 2 hours. So if the pilot were to fly along one of these vectors, he'd wind up just out of range. And even with Captain Duke's courage, he'd fly no farther because he